Welcome everybody. Today we're going to be going off of what we learned last time about our introduction to normal distributions, and we're going to start talking about what we call the empirical rule. Alright, so your learning targets for today are being able to understand the connection between relative frequency histograms, normal distributions, and the empirical rule, and using the empirical rule for normal distributions to solve problems. Okay, so this first one is a big one, relating what we did in our previous videos with what we're going to be doing from here on out. Okay, and then once we learn the empirical rule, we'll need to be able to apply it in different situations. Alright, so last time we talked about this thing called standard deviation. Okay, standard deviation, and it was labeled with what we call a sigma. Okay, this is a lowercase sigma, and part of the empirical rule talks about your standard deviations. So the first part you need to know is that approximately 68%, that's an important number to remember, of the data in a normal distribution is within one standard deviation of the mean. So what that means is if my mean is right here in the middle, if I go one standard deviation in both directions, 68% of my data is going to be included in this blue area. Okay, so no matter what, if I have 100 people and it is normally distributed, then that means 68 people are within one standard deviation of the mean. The second part of this, we talk about within two standard deviations. So again, the mean is here. Now I'm going two standard deviations in both directions. Okay, now what trips people up a lot is that when I say two standard deviations, some people think that just means the entire span. Okay, but what I mean is in both directions. So it goes two standard deviations this way and two standard deviations that way for a total span of 4 standard deviations. Okay, and so inside 2 standard deviations is 95% of the data. So if you think about our example that I talked about last time, where we have 100 people and our data is normally distributed, then 95 people would be contained within 2 standard deviations of the mean. So this area in here would account for 95% of our data. Lastly, okay, now we're going to start talking about within 3 standard deviations. So again, the mean is here. We're going to go 3 standard deviations this way and 3 standard deviations the other way. Okay, and this is going to contain 99.7% of our data. And I know what you're thinking, that's oddly specific, and yes, you do need to remember 99.7. Okay, so ultimately the 3 numbers you need to know are 68, 95, and 99.7. Okay, so if you ever take a statistics class in the future, sometimes it's even called the 68, 95, 99.7 rule. Okay, here we will specifically talk about it being called the empirical rule, just because I think it's a lot easier to say empirical rule rather than say all those numbers. Okay, so right now we should have a definition for 1 standard deviation, 2 standard deviations, and 3 standard deviations. And real quick, just to summarize this last thing, this last little line down here, okay, the empirical rule applies most accurately to population data, mostly because the population is really big. Okay, so what we'll do is we're going to hope to take large enough samples of the population so that we can apply it to the population. Okay, so that means, for example, maybe we don't have the means to survey all the people in the United States, but if we get a big enough sample, we can apply what we find in that sample to the population and make assumptions about the population. So let's start with a few examples. In these first few, they're going to shade the region that they want us to find the percent of. Okay, so in this one, it's going to be shaded red. Okay, some things that we're going to need to be able to do is determine each percent and explain how we got that. Okay, not in this one, but in future ones, we will need to be able to shade the corresponding area under the normal chord that they are talking about. Okay, and then lastly, we should be able to tell whether the distribution represents population or sample data. Alright, so let's take a look at this first one. Notice that we're right at the mean, and it looks like we go all the way through the tail of our data. Well, what I want you to think about is under the entire curve. Okay, so if you imagine if I redraw this, something like that, okay, under the entire curve contains 100% of my data. Okay, so all my data points, okay, if you imagine you find all the relative frequencies and all of these little rectangles are contained inside these normal distributions. So 100% of my data is located in the area here. So if you imagine, if I'm just going from the mean to the end this way, that represents what percentage of my data. If you answered or thought to yourself 50%, that is perfectly correct. Okay, notice you can even tell area-wise that this red area is exactly half of my total area. So above the mean would be 50% of my data. Alright, as far as whether this would be a population example or a sample data, remember that we defined standard deviation as when it is sigma, okay, sigma, okay, that always implies population. Okay, if it were a sample, remember that that is labeled with an S. Okay, so S is sample, sigma is population. Okay, on to the next example. This one is asking us to determine the percent of data between the mean, that's here in the middle, and two standard deviations below the mean. Okay, so that means to the left of the mean. We're going 2 standard deviations. Notice that these are S's, so this must be talking about some sample data. Okay, so let's review what we talked about in this lesson so far. Okay, we had something called the empirical rule, okay, that described what happens when we go a certain amount of standard deviations from our mean, and specifically the one I want to refer to is the one that goes 2 standard deviations in both directions. Okay, so remember that when I go 2 standard deviations in both directions, okay, the area inside here, okay, this red area in here, okay, and hopefully you wrote this down, this labels 95% of my data. Okay, this entire red area is 95%. But what I want you to notice is that this area is not asking us to find the area in both directions. Instead, this is only half of this 95%. So what you would need to do is you would take your 95% and you would need to divide that by 2. Okay, because I only have half of it. So if I divide that by 2, I should get 47.5%. Okay, so this area right here only labels 47.5% of the data. For this next example, if you'll notice, the last 2 examples we always did something with the mean, okay, either above the mean or between the mean and 2 standard deviations. This one is asking something completely different. What percent of data is between 1 and 2 standard deviations above the mean? So this red area in here, again, I'll label that this is the sample because the standard deviations are labeled with S's. Alright, so we're going to have to kind of combine two ideas here. So if I redraw my curve, by the way, you'll get a lot better at drawing these curves as we continue. Okay, if my mean is right here in the middle, okay, when I go out 1 standard deviation in both directions, the area contained in here is, again, 68%. So that is 68%. Now imagine I need to go out 1 more standard deviation, okay, because again this is between 1 and 2 standard deviations, so from the mean out 2 standard deviations in both directions. Okay, that's another area, and then this entire area would be 95% of the data. Notice how these overlap in this area. Okay, this is still 68% of the data. Okay, so we have 68% in here. So what I'm going to do to set this up is I need to find just the area in these blue areas on the wings outside of the 68%. Well, if you know about area, okay, what I can do is I can just take this 95% and subtract the red 68%, and that'll give me these areas out here. Okay, so if I do 95 minus 68, which would equal 27%. So, in other words, these blue areas in here, okay, this one here and this one here, combined to be 27%. So this one and this one both combined to be 27%. Now notice in my problem that I only want this area. Okay, so just like last time, I'm going to take 27% and I'm going to divide it in half because I only have one part of it. I don't have this other area over here. Okay, I don't have that. So if I take 27 and I divide by 2, that would give me 13.5% of my data. Okay, so that would be your final answer. As always, if this doesn't make sense, make sure you get a hold of me and I will come explain it to you in a different way. This next example also does not deal a whole lot with the mean, although at some point you do use the mean in all of these. But what I want you to think about, okay, so I need to find the percent of data that is more than 2 standard deviations below the mean. So if you imagine 2 standard deviations below the mean would take me right there. So this is everything past that. Okay, so everything out there. Well, we can use what we know about 2 standard deviations away, because if I go 2 standard deviations in both directions, okay, remember that represents, okay, this area represents 95% of my data. Okay, and so if you remember, 100% of my data is located underneath my curve, so like all of this, okay, everything under the curve is 100%. Okay, if this black area is 95, then in these tails over here and over here, I must have 100% minus 95%, meaning that there should be 5% located in these two combined tails. Okay, and if you're starting to notice a common theme, okay, a lot of times that they only give us half of what we end up finding. So for example, these two things, okay, this end here and this end here add up to 5%. So that means I would need to take 5% divided by 2. So that means 2.5% would be located in each tail. Okay, and so ultimately that is the question that they are asking. So your answer would be 2.5%. Alright, so let's move on to something that actually has data. Okay, actually has a mean, actually has standard deviation, so that we can get an idea of how this is all going to look. Okay, they haven't shaded the region for us, so we will have to do that for ourselves. Okay, again, this is sigmas, so we're specifically talking about a population. Okay, so they tell us that the mean of these adult males must be 70 inches. Okay, and the standard deviation, okay, must be this distance, which is from 70 to 74. So in other words, mu is 70, sigma must be equal to 4, because as you can tell, I go from 70 to 74, which is 4 units. Alright, so they specifically want us to find the percent of adult males who are between 62 inches tall and 74 inches tall. Okay, so if you notice, 62 inches is right here, 2 standard deviations below my mean, and 74 is right here, 1 standard deviation above my mean. Alright, so the area we're trying to find is this one right here. Okay, now there are a number of different ways that you can solve these questions. So ultimately, I mean, if you find a way that works for you and you get the right answer, go for it. Okay, I'm going to explain it to you one way. If that doesn't work, make sure you ask questions, and I can definitely explain it to you a different way. Alright, so what I'm going to do is I'm going to redraw this thing to just give us another point of reference. So if you think about, if I go 1 standard deviation in both directions, so 1 sigma and 1 sigma, okay, that contains 68% of my data. Okay, so in here, this black area, okay, right in here, is already 68%. So all I need to find is this red area and add it to 68, and that would be my answer. Okay, so well, what we're going to do is we're going to think about, well, 2 standard deviations out. Okay, so 2 standard deviations, okay, 2 standard deviations is 95%. Okay, so one thing to think about is we need to calculate how much more that is than 68. Because if I can calculate how much more, I can figure out these blue areas in here. And as you can tell, this blue area corresponds to this red area. It's ultimately what I'm trying to find. Okay, so kind of like we did in the last example, we have to take 95 minus 68 to get 27. Okay, and again, I'm only looking at half of that amount because this blue area and this blue area would be this 27. So what I need to do is I need to take 27 divided by 2 to get 13.5. Okay, so this red area right here must be equal to 13.5%. Okay, so overall, my answer would be 68% plus 13.5%, giving us a grand total of 81.5%. I'm running out of room. Okay, so 68 plus 13.5 would be 81.5. Double check my math on that. I'm doing it without a calculator. But ultimately, understand that what this is saying is that 81%, according to this sample survey, 81.5% of adult males are between 62 inches tall and 74 inches tall. Alright, for this next one, I'm going to show you a slightly different method that may simplify things for you a little bit. For me, this is probably how I would lean towards doing them. It kind of just simplifies things at the start, and if you don't follow along, definitely stop me and bring me over and I will certainly help you. So, we need to know what percent of adult females are taller than 68.5 inches. So from my graph, I should be able to identify that my mean, or mu, is 65 inches. Okay, and my standard deviation, well, how far do I go this way? It's from 65 to 68.5. My standard deviation would be 3.5 inches. Alright, so ultimately they're having us find 68.5 inches, but we want taller than. Okay, so taller than would be all of these heights that are bigger than 68.5. Alright, so here's where it's going to get a little bit different. If you imagine, right here at the mean, I should know that that splits my data perfectly in two. So everything above the mean is 50% of my data. So if I can find this blue area in here, I can simply subtract that from 50 to get my red area out here. Okay, because red plus blue would equal the 50% of the entire tail on the right. Okay, so that's a little bit different than the way that I've been setting it up. But essentially, it all works out the same way. So, again, let's look at an example. Okay, so if I'm here at my mean, and I go one standard deviation in both directions, okay, again, I'm trying to find this blue area up here. Okay, so that's one standard deviation out. Okay, so one standard deviation, one standard deviation. Again, from the empirical rule, this is 68%. Okay, well, if I'm only trying to find the blue area that corresponds to that blue area up there, that's half of 68, which is 34. Okay, and so if this whole side, okay, everything this way is 50%, well, then this red area must be able to be represented by 50 minus the blue area, which we found to be 34%, giving us a total of 16%. Okay, so there must be 16% of females taller than 68.5 inches. Alright, at this point, it may be good for you to try pausing the video and trying to figure this one out on your own, and then checking your answer with mine after you've already tried it. Okay, so if you wanted to, just pause the video, work it out, come up with an answer, and check to see if you get the same answer as me. Alright, so trying to figure out here what percent of history test scores are between 63 and 70. Okay, so 63 is my mean right here, and again you can tell that these are samples. Okay, they're not the population because it's S's and X bars. So x bar, which is the sample mean, is 63, and the standard deviation of the sample must be, well, from 63 this way is 7. Okay, and this thing is specifically asking us between 63 and 70, what is this area? Okay, so this should be easy enough, because if you remember, if I go one standard deviation this way and one standard deviation this way, okay, that should contain, so all of this should contain 68% of our data. Well, if I'm only specifically talking about this black area, which is half of that, all I need to do is take 68 divided by 2, and that would give me the 34% that I'm looking for. So, on this history test, it looks like 34% of people scored between 63 and 70 points. Okay, last example. We're going to try to put it all together on this one. So, they don't give us any mean or standard deviation written on our normal curve. Okay, notice that it's just blank. This is how you will see them on tests and on quizzes and stuff like that. Okay, you're gonna have to take that out of the context of the situation. So, if you read, it says, most days Teresa eats dinner at 6 p.m. So think real quick, what is that telling us? Okay, so if most days Teresa eats dinner at 6 p.m., what do you think that pertains to in this situation? Alright, if you said that that pertains to the mean, you would be exactly correct. Okay, so most days she eats dinner at 6 p.m. Another way to say that is, on average, Teresa eats dinner at 6 p.m. So what I'm going to do is I'm going to label this as 6 o'clock. Okay, remember that goes right in the middle. Alright, and then the standard deviation is 15 minutes. Okay, her dinner time can be modeled using a normal distribution with a standard deviation of 15 minutes. So 15 minutes. Okay, so then this next time would be 16 minutes, or 6:15, and then this one would be 6:30. Okay, that's 2 standard deviations out, and this last one is 6:45. Okay. If I go backwards, this would be 5:45. Okay, 5:45, 5:30, and 5:15. Okay, again, I'm going 15-minute intervals because of what my standard deviation is. Alright, so the question is asking, what is the probability that Teresa will eat dinner before 6:30? Alright, so the first thing I need to do is I need to identify 6:30 on my normal distribution. So, that's right here. Before 6:30 would be everything on this side of 6:30. Because if you imagine, 5:15 is before 6:30, 5:30 is before, and so on. All of these times are before 6:30. Okay, so like we said, here is my mean. Okay, 6:30 is 2 standard deviations that way. Okay, so let's think about that real quick. If it's 2 standard deviations, okay, if I redraw this, okay, that's my mu. If I go 2 standard deviations this way, and 2 standard deviations this way, okay, within 2 standard deviations should be 95% of the data. Okay, so that would be between 6:30 and 5:30. That should be 95%. But notice that I have this little tail area. So what I'll need to do here is using this 95%, I know that 100% of my data is under this entire curve, and so if this middle part is 95, then I know that 100 minus 95%, giving me 5%, is located in these tails. Okay, but just like in previous examples, okay, I only need this one tail. Okay, so I have 2, so what I need to do is take 5%, divide it in half, or divide it by 2, to give me 2.5%. Okay, so this area right here would only be 2.5% of my data. Okay, so from this line over. Okay, well, if I add that to the area in here, which was 95%, okay, I get 95 plus 2.5 for a grand total of 97.5%. Okay, so remember that what this was asking is it was talking about probability, which is all about chance, so the chance that something happens. So there's a 97.5% chance that Teresa will eat dinner before 6:30 p.m. Okay, that concludes all the examples that we are going to be doing in this video. So let's revisit our learning targets. So at this point, you should be confident that you know the connection, okay, between relative frequency, histograms, normal distributions, and the empirical rule. Mostly what that's talking about is that all of the data, okay, that you get your relative frequencies, your histograms from are located under our little normal distribution curves. So if you imagine, there's all these little histograms with relative frequencies under here. That was terrible. Like that. Okay, and they're all related because they all contain data points in each of these little rectangles. Okay, and the empirical rule tells us, based on the standard deviation, what's contained in those histograms. Okay, and then the next thing you should be able to do is use that empirical rule, the 68, 95, 99.7 rule, okay, to say that between a certain given standard deviations, there's this much data. Okay, so what I want you to do now is you need to come grab 15.2 from me, from the book, and then finish 15.2 assignment. Remember that those are two different things. This thing is from the book. This is a worksheet. Okay, it'll say assignment 15.2. Once you're done with those, okay, you're now ready for the mid-unit quiz. Okay, so don't go on to Intro to Z-scores until you have done this assessment. Okay, so come talk to me and I'll give you what the quiz criteria is, and we'll discuss it just to make sure that you understand what you need to be doing. Okay, again, this happens after 15.2. So don't come to me before you've finished 15.2. I will ask. Okay, so good luck with 15.2. If you have questions, make sure you ask.